time series data, a simple example is this now function. We can just use it to extract what time is it, like the year, the month, and also the day and the time. And also, because this specific variable is in date time variable, we can actually do calculations for different uh, date. For example, you might have already solved this kind of similar question when you first learn coding, like compute like how many days between 2 days, and also like today is March 11th. After 100 days, what is the date, right? We need to do the calculation by ourselves. But in Python, actually, if you just convert it using the datetime function, you can see this is a year, month, day, and also can give it a time, like say 8:15 in the morning, and we can directly compute the difference between two time day, like how many days between them, and also like how many seconds remaining. Um, and another way is we can use a time delta function. It can convert a number into a time date variable. This way, we can just add up an integer to an existing date. For example, here, this one, the default way is days. So 12 this time, instead of a number, it means 12 days. So we can just compute like after 12 days, what is the time? So that's how like a basic Python to do with date, time, data time variable. But a more important thing is in pandas, we can use this date time variable as index for each data frame. So let's see. So I load these packages and I create all these different date time variables and save it in this list. And I use, instead of using like integers as index, this time I use all these dates as index. You can see when I run the program, now this is the output. And this series is like for each day, we have a specific value for it. And of course, we can still use the index from based on the integer numbers to get to retrieve the data. But also we can use human readable like date strings to extract those data. No matter is like in this format or like in this format, pandas will just understand how that means and extract the corresponding information from this series. Yeah. And another another example is this one. So assuming I create a very long time series data frame, and this one I generated 1,000 random integers. Sorry, 1,000 random numbers, floating point, and then I generate 1,000 date time variables and use them as index. Here, this date range function is a function used to generate these different date times. I will also explain it later. So basically, the result is a 1,000 row series, and the index is just a different date. And because by default, the date range function we will create based on the day. Like each day, we just create a new time, daytime variable. And let's see if I want to retrieve information from just the year 2001, I can just give it 2001, and all the information related to that year can be extracted. And also, if I just give it a month, so all the information for May will be extracted. This will be very like convenient, especially in the economics field, like you want to specifically focus on data from a specific period. And also, if you want to get information within a specific range, you can just give the date of that specific start and end of that range, and the information can be extracted. Yeah, of course, because it's a time date, right? So we know sometimes for like today I measure 3 data points. Maybe tomorrow I just have 1 data point. So it's possible that there is duplicate index. So if, for example, this one, there are some duplicates index and it is totally fine. and we can use the .index is unique function to check if the index there's a duplicate. If it's false, it means there is duplicate. And if I just want to retrieve the information on this specific day, I can get all the data points collected on that day. And also, uh, we created that longer time series data frame using that date range function. So this function basically you can give it a start time and end time, and the default frequency is by day. So it just increase one day by another and give you all the time daytime index. And of course, you can also just give it a start day and using the period parameter to say like how many index you want. It can just create based on that. And similarly, the default is just increase by one day. And you can also give it the end date, and you create the index backwards, and create this 20 daytime index for you. And it also takes many other like parameters. So for example, here frequency BME means business day, and ME is monthly end. So this is a very common terminology in business area. Like sometimes for every month, like at the end of every month, they will do some calculation and for the price and earning those things. So month end is like a typical you can say just now still whereas so all these daytime index, but this time it's just every month and by the end of the month, like the last day of the month. So this table only summarizes some commonly used parameters, and in the future, if you have if you need to analyze this data, please check their menu. There are actually very many different kind of parameters you can use. And another thing about time series data is about time zone. We know Toronto, we just changed the time last Sunday. Yeah, so it's very unpleasant to work with this thing. But the good thing is in Python, we can use this pytz library to handle time zones. And usually people just convert whatever time zone, just convert it to UTC time and then do calculation. This way it can be like a uniform way to compute time. And but the default, like the previous time TS data frame, I think where is it? Create, yeah, like the one I created at the very beginning. Yeah, this one. Default, there's no time zone. Like we didn't say what time zone it is, so it's none. But we can definitely set the time zone use a TZ variable in the data range function. And we can also use a TZ localize to convert, to set up the time zone for a specific time series index. And we can definitely convert it to another time zone just using TZ convert. And also, by default, everything will just be converted to UTC if you want to do some time calculations. Yeah, that's some basic information about time series data. Another thing about time series data is like usually the data set when we collect it, maybe it's like every 5 minutes or every day. But when we do analysis, we just want to know like what is the average data in 1 month. So we can basically just for all those data sets, we can just do some average calculation and narrow down to like every month, just give a one value. So we can actually do it like this. So this is like a data frame that's from January 1st to April 9th. Every day there's a value. So we can use a resample function to like downsample the entire data set into a monthly basis. So here ME still means like month end, and mean means like we just need to calculate the mean value in that specific month. So after this, now there's only 4 entries each month there's a mean value for that specific month. And this idea is called downsampling. It's like a lot of data sets just narrow down to a smaller group of data points. And similarly, we can this is a data set for like every minute, and create like a 12 data set. Every minute there's one value, and we can narrow it down to 5-minute range. So now it's like every 5 minutes, what is the cumulative results? Because I use sum, so it's like a cumulative results. But this actually this is actually a tricky part. It's like sometimes like in their field, this calculation, like you can see here is from 0 to 11. We only have like 12 time points. But after like these results, you can see there's 0 to 5, 5 to 10, and that's it. There's no. That's because like they use this kind of window, like every 5 minutes, so it's like 5 time points, and you can do it like from the left side, 5 time points, and next 5 points. You can also compute from the end of the list. I mean, of the time series index, like the last 5 and the last the second last 5. So these two parameters, closed and the label, actually determines like how this thing is computed. So, for example, this one closed from right, it will just compute from the end of the of all these index, and but this one is a label from right, so it's not, instead of compute from the end, it just also extends this index and all the way to 15. I mean, so basically just from 10 to 15 and 5 to 10, like this kind of way to do the calculation. I know this is tricky, but yeah, it's just a way for the function to compute the to do the downsampling. Just be careful when in the future if you need to handle this kind of data set. Another another thing about, I mean, we have downsampling, of course, we have upsampling. So upsampling is like maybe you have 5 time data point, you just increase it to 50. But let's see this example. We have two date, and every city has a value. If we use similarly use a resample function, but we use a as_freq function to upsampling it, you can see there are many NA values. That's because we don't have data on those days, right? It's like a fake, nothing is there. So of course it's NA. So similar to that remove NA function we learned earlier in this course, we can use a forward fill to change, I mean, to fill those values. Just all the values just equal to the day on the first day. But of course, I mean, this kind of it's not true. It's fake data, right? You only do it if it's okay in your field, or maybe you can like assuming like there's some kind of strategy, maybe using the average to fill those values. That's also one way to do this upsampling. So the thing is, I mean, this is for like, this example is for like economic area, like, you know, downsampling. But actually in machine learning, in data science, downsampling and upsampling is also a very popular idea, because especially for upsampling, usually you have some techniques, like you have a figure, like you do want to do image classification, and we only have like 1,000 images, but I can rotate the image 45 degrees. It's not the same, but I mean, it's the same image, but different. When you rotate it, looks different. This kind of way, you kind of increase the all the image to another new one, and also maybe you can change the resolution of the image. You just reduce the resolution and make it blurred, and that's also another kind of image. This kind of way, like there are many ways to do this kind of upsampling in machine learning, like more smart than this kind of forward fill. But of course, that's still like a fake data, but we know that the rotate doesn't change the quality of the image, right? So and downsampling, I would say, is more used in there's an idea called imbalanced classification. that can, for it's very common in the medical area. Like maybe you have 1,000 healthy persons data, but for cancer patient you only have 10. If you compare this 1,000 with 10, the model can like have errors because there are too many healthy patients. The model just don't know what a cancer patient look like. So we can do downsampling, just randomly select 10 patient, 10 healthy person, then compare with. That's a very commonly used strategy to make sure like a different group has the same number of samples. This way, like the model can correctly learn the patterns within the dataset. So any question about this time series? Okay, let's see a simple example analysis, the stock data, like how we can analyze some real life like time series data. So this is an image got from the VOO. This is a S&P 500 ETF in the US stock. And you can see it's usually for a stock, it has a open value price, like in the morning, 9:30 when the market opens, what it is price, and also in like what is the highest price, what is the lowest price today, and also the volume, like how many stocks are there on the market. So of course, all these points on this curve show the price of this stock in this here is 1 year, like in this 1 year range, what is the price is. So we can actually do some similar analysis using this data. So I have a data set called stock data, and I just read it using read CSV. You can see I use the date column as the index. So now this is like a time series data. Each index is just a different day. And similarly, we have open price, high price, low price, and also the volume. This column is nothing, like means nothing, just only, so we just remove it. Now it's a clean data frame and we can draw some curve. First, let's check like what is the highest value change based on the date. So I use the line plot X, like the date as a index, sorry, X-axis, and the highest value as a Y-axis. Yeah, you can see this is kind of how the stock changes in different months. Is month? It's different day. Yeah, but some like in our previous question, like we can use resample to downsample in the data set. So here ME to like a monthly end. So we don't want to check like the everyday change. I just want to know every month what's the average value in that month. So I just downsample it, compute the mean, and use a mean value to check how the stock price change every month from 2006 to 2018. Yeah. And also, I mean, this just shows the highest value. We can also, sometimes we want to know like how the stock changes, like what's the difference between every time points. So we can use this function called .diff. It basically computes for every data point, it computes its difference from its previous data point. This way we know, instead of knowing the actual value, we know how it changes, right? We want to know like how the pattern of the entire stock. So we can compute the difference and then similarly still using the time as the x-axis, but now we can say, okay, in 2008, there's like the famous like the economic crash. Yeah, so there's a huge changes, and in other years maybe there aren't any changes. Yeah. So the last commonly used technology, not technology, I mean analysis way is called moving average. This moving average is like you use a window, like for example, 120 means I use a window that computes the average value of 120 data points. And then I move next, move to the next index and compute the next 120 values. What is the average? This way it's like using this window, instead of check the actual value in that date, I can see a kind of average pattern in this along this whole time. So the function for calculate moving average is called rolling. You just need to give it the window size, like how many data points you need to compute the average value each time. And then it's kind of a way to smooth the curve and make sure like it reflects more like the patterns within the data set to give you like a hint about how to like how should you proceed with the stock? Should you buy it or should you sell it? Yeah, that's basically some commonly used functions and strategy we can do with time series data. It's I mean, it's very popular or very common in economics. Maybe in other areas, it's not that common because, especially in medical area, we wish we can have time series data, but it's not possible. It's too expensive. So, but yeah, if you have in the future, if you find any job in this area, you might need to handle with this data set. Yeah. Any question about time series?